Welcome to the Horizon Audiofiles, a podcast of the Defense Horizon Journal. The Defense Horizon Journal is a professional and academic journal that features essays, reports, and analyses covering geopolitics and law, security and defense policy, peace and conflict studies, applied military science, as well as developments in weapons technology. For more information, go to www.tdhj.org.
Episode number 40. Innovative Technologies in the Development of Explosives and Pyrotechnics for Modern Warfare, by Doris Dasovic. The role of explosives and pyrotechnics in military technology. The rapid evolution of technology has introduced unprecedented innovations in military applications, particularly in pyrotechnics and explosives. Developments in nanotechnology, artificial intelligence, AI, and three-dimensional additive manufacturing, 3D printing, have transformed the design, deployment, and security of explosive devices. These new technologies hold immense strategic benefits in military applications, but also raise serious geopolitical and ethical concerns. Explosives have been a key component of military operations for centuries, with ongoing advancements making them more precise, powerful, and effective. Pyrotechnics, such as signal flares and illumination rounds, have also evolved to serve in critical tactical roles. The development of smart explosives and sophisticated detonation systems has transformed battlefield strategies. However, these innovations must be carefully managed to prevent misuse and mitigate risks posed by non-state actors. The evolution of explosive materials has been a cornerstone of military engineering, progressing from black powder to today's compounds. The introduction of TNT, RDX, and PETN in the 20th century revolutionized explosive power and efficiency. The first recorded use of black powder, a mixture of charcoal, sulfur, and potassium nitrate, dates to 9th century China, where it was employed in early firearms and rudimentary explosive devices. The introduction of nitroglycerin in the 19th century marked a significant leap forward, though its instability limited its practical applications. This challenge was overcome with the invention of dynamite by Alfred Nobel in 1867, which provided a safer and more manageable form of explosive power. The 20th century witnessed further breakthroughs with the development of high-explosive compounds, including TNT, RDX, and PETN. These materials offered greater stability, increased explosive force, and enhanced versatility, revolutionizing both military and industrial applications. As technology continues to advance, modern research focuses on producing explosives with controlled detonation properties, reduced environmental impact, and improved safety in handling and storage. Understanding the historical progression of explosive materials is essential to appreciating the innovations that now define modern military strategy. More recently, nanotechnology has enabled the development of more powerful yet controlled explosive materials. By manipulating substances at the molecular level, scientists can enhance stability and effectiveness, reducing accidental detonations while maximizing impact. One notable application is the use of nanoaluminium in energetic materials, which significantly improves combustion rates and overall explosive efficiency. Nanoaluminum particles enhance the reactivity of traditional explosive compositions, allowing for more controlled and predictable detonation sequences. This technology is already being explored for use in advanced military-grade explosives, offering increased power while reducing sensitivity to unintended detonation. Nanotechnology in explosives development. Looking ahead, nanotechnology is poised to play an increasingly significant role in military innovations, particularly in the field of explosives and ordnance. Scientists are already making strides in developing self-repairing nanostructured materials, which could revolutionize the reliability of explosive devices. These materials would allow explosives to autonomously restore structural integrity if compromised before detonation, ensuring their effectiveness in critical combat scenarios. This breakthrough could drastically reduce the likelihood of malfunctions that may render a device ineffective or, conversely, cause unintended detonations. Additionally, AI-integrated nanotechnology is paving the way for smart explosives with the ability to modify their detonation power based on real-time environmental factors and target characteristics. Current advancements in nanotechnology have already enabled the development of nano-energetic materials that enhance explosive efficiency and stability, while AI-driven targeting systems are improving precision in modern munitions. Some military-grade explosives now incorporate sensor-based fuse mechanisms that adjust detonation based on impact conditions. However, fully autonomous, AI-regulated explosives capable of dynamically altering their energy output in response to real-time battlefield data remain largely theoretical. While research is underway to integrate nanoscale sensors with AI-driven decision-making systems, such self-adjusting explosives have yet to be deployed in active military operations. Future developments may allow these smart explosives to analyze environmental data and modify their detonation profile accordingly. But these capabilities are still in the experimental phase. These intelligent explosives could adjust their energy output to maximize damage against hardened targets, while minimizing collateral impact in civilian areas. Such developments could significantly enhance the precision and efficiency of military operations, providing armed forces with more adaptable and controlled weaponry. As nanotechnology becomes more deeply embedded in military strategy, governments, defense agencies, and research institutions must collaborate to establish ethical and legal frameworks for its application. Without proper oversight, these advanced technologies could fall into the hands of rogue actors or hostile entities, leading to dangerous and unforeseen consequences. By implementing strict regulatory guidelines and international agreements, the global community can ensure that the advancement of nanotechnology in military explosives remains both responsible and secure. However, the development of such regulatory frameworks faces significant obstacles. First, the rapid pace of technological innovation often outstrips the ability of policymakers to draft, debate, and implement comprehensive regulations. Many countries prioritize military superiority over regulatory oversight, leading to a lack of transparency and cooperation on international arms control agreements. Second, nanotechnology is a dual-use technology, meaning it has both civilian and military applications. Many of its advancements are developed for commercial or medical purposes before being adapted for defense, making it difficult to regulate without impacting beneficial industries. This overlap creates a regulatory gray area where military research can continue under the guise of civilian innovation. Finally, geopolitical tensions and national security concerns often prevent countries from agreeing on enforceable international standards. Nations with advanced military nanotechnology programs may be unwilling to impose restrictions that could limit their strategic advantages. Additionally, enforcing compliance across multiple nations, especially non-allied or rival states, remains a major challenge. Without a coordinated global effort, the risk of proliferation and misuse will continue to grow. Artificial intelligence in explosive threat detection. Artificial intelligence is revolutionizing the deployment, detection, and neutralization of explosives in modern warfare. One example is the integration of AI-driven reconnaissance tools with satellite imaging and ground-based sensors to detect and neutralize explosive threats before detonation. These systems can rapidly process vast amounts of data, recognizing potential dangers with a level of speed and accuracy that surpasses human capabilities. According to the U.S. Department of Defense, AI-driven threat detection technologies significantly reduce false alarms while improving the precision of countermeasure deployments. AI is also transforming explosive ordnance disposal (EOD) operations. Traditionally, bomb disposal has been a high-risk task for human specialists. However, AI-integrated drones and robotic units can now autonomously locate, assess, and neutralize explosive threats with minimal human intervention. These autonomous systems can operate in hazardous environments, reducing the risk to military personnel and increasing the success rate of EOD missions. Beyond detection and disposal, AI is being utilized for predictive threat analysis. Machine learning algorithms can evaluate patterns of enemy activity and predict the likelihood of explosive threats in specific areas. This proactive approach enables military forces to take preemptive action, mitigating risks before they materialize on the battlefield. AI-powered reconnaissance tools, when combined with satellite imagery and real-time data analysis, can provide invaluable insights into enemy movements and explosive deployment strategies. Ethical considerations and regulatory challenges. While AI and nanotechnology offer tremendous benefits for military explosives, their integration also raises pressing ethical and security concerns. Determining responsibility in the use of AI-powered systems in warfare may not be as complex as often suggested. Just as a soldier is held accountable for pulling the trigger, responsibility for an AI-enabled action could similarly rest with the human operator authorizing or overseeing its use. While it is true that AI lacks moral reasoning and operates on algorithms and data patterns, this does not eliminate the role of human judgment in its deployment. Suppose an autonomous system were to mistakenly identify a civilian as a threat. In that case, the accountability should remain with those who designed, authorized, or supervised its use, much like any other military tool. However, this reinforces the need for clear accountability structures, rigorous oversight, and internationally agreed upon rules of engagement to ensure ethical and legal use of AI in warfare. Similarly, adversaries could exploit nanotechnology-driven smart explosives and self-repairing materials if they are not properly secured. There is a growing concern that non-state actors or terrorist organizations could gain access to these advanced technologies, potentially creating highly unpredictable threats. Governments must implement rigorous cybersecurity measures and regulatory protocols to prevent the unauthorized proliferation of these innovations. The increasing integration of artificial intelligence, AI, and nanotechnology in military applications has prompted discussions on the need for comprehensive global governance frameworks. According to the Carnegie Endowment for International Peace, without proper regulations, the unchecked advancement of AI and nanotechnology in military systems, particularly explosives, could escalate armed conflicts and increase risks to civilian populations. Similarly, the U.S. Department of Defense emphasizes that while AI enhances military efficiency, its rapid implementation without ethical oversight may lead to unintended strategic consequences. However, the debate on AI governance in military applications is far from universal. Western nations, particularly those in Europe, often emphasize adherence to international law and ethical restrictions in military AI and advanced weaponry. In contrast, authoritarian states such as Russia, China, and North Korea prioritize strategic advantage and military dominance, often imposing fewer limitations on their use of emerging defense technologies. This disparity creates a global security dilemma. How can democratic nations uphold ethical leadership in warfare without falling behind in technological capabilities? This challenge is threefold. First, democratic nations, especially in Europe, must strike a balance between advancing military technology and adhering to moral values. This balancing act becomes increasingly difficult as adversaries who disregard ethical concerns may gain a tactical edge in AI-driven warfare, cyber operations, and autonomous weapon systems. Second, the lack of a unified ethical and legal standard presents direct security risks. Countries that impose fewer restrictions on AI in military applications may gain strategic superiority, compelling others to weigh the extent to which they are willing to compromise on ethical concerns to maintain deterrence. The Carnegie Endowment for International Peace warns that this technological arms race could undermine existing global security structures and lead to destabilization. Third, even among Western allies, differences in ethical, moral, and legal standards impact military interoperability. The United States adopts a pragmatic, capability-driven approach to AI in warfare, while Germany imposes more restrictive oversight. In contrast to these two perspectives, France pushes for technological advancement with a cautious regulatory approach. These disparities create challenges for NATO and allied military operations, where interoperability depends on shared military doctrines and standardized regulations. Effective collaboration requires ongoing dialogue, unified ethical guidelines, and clear protocols for the integration of AI and autonomous systems in joint military efforts. Ultimately, addressing these challenges requires a strategy that balances ethical responsibility with security imperatives. While maintaining strict moral standards may leave democratic nations vulnerable, an unchecked arms race in AI and autonomous weaponry could destabilize global security. Finding common ground among Western allies and engaging with broader international players will be crucial to shaping the future of military technology while preventing ethical erosion in modern warfare. The future of AI in battlefield intelligence. The continued evolution of AI will further enhance battlefield intelligence and combat capabilities, including those involving explosives and pyrotechnics. Future developments may include AI-driven swarm intelligence, where groups of autonomous drones coordinate in real time to conduct reconnaissance, threat assessment, and even explosive ordnance delivery or neutralization. These drone swarms could autonomously map enemy positions, identify targets for explosive payload deployment, and relay critical data to command centers without constant human oversight. This technology would enable militaries to execute highly coordinated operations such as area denial using smart explosives, synchronized strikes, and automated mine-clearing missions while minimizing risk to human personnel. The U.S. military and several defense agencies globally are already experimenting with AI-controlled drone swarms that can carry and deploy explosives to assess their effectiveness in complex combat scenarios. AI-powered robotic soldiers equipped with advanced sensors and adaptive learning algorithms could be deployed in hazardous environments, including explosive ordnance disposal, EOD, operations or logistics missions involving transport of pyrotechnic materials. In the future, humanoid or quadruped robots may assist in high-risk explosive tasks alongside soldiers, offering real-time situational awareness and precision handling of volatile payloads. Moreover, integrating AI with quantum computing will significantly accelerate data processing for applications such as the detection and disarming of improvised explosive devices, IEDs, threat prediction, and decryption of enemy communication related to explosives logistics. This fusion of AI and quantum capabilities could redefine cryptographic and counter-explosive warfare, allowing for faster identification and neutralization of threats. AI-driven holographic battlefield simulations may also help visualize explosive impact zones or predict chain reaction risks, aiding tactical planning and minimizing collateral damage. Future AI-powered command centers could simulate scenarios involving explosive usage in urban and open terrain, adjusting deployment strategies in real time. These dynamic simulations would enhance decision-making, reduce operational risks, and improve the precision of explosive engagement in various military contexts. Ultimately, as AI continues to transform modern warfare, its integration with explosive technologies presents both powerful capabilities and new risks. Ensuring ethical deployment, robust cybersecurity, and international cooperation will be essential to mitigate the misuse of AI in contexts involving pyrotechnics and explosives. Future AI-powered command centers could simulate multiple battle scenarios simultaneously, adjusting strategies based on real-time intelligence and adversary movements. These simulations could provide dynamic wargaming environments where commanders test various tactical approaches under changing conditions. This would enhance decision-making, reduce operational risks, and improve training for military personnel. Ultimately, these advancements in AI, robotics, and quantum computing could redefine modern warfare by enhancing strategic agility, reducing human exposure to combat risks, and providing a decisive technological edge in battlefield intelligence. However, the successful implementation of these technologies will require strict ethical oversight, robust cybersecurity measures, and international cooperation to mitigate potential misuse. 3D printing and its military applications. The rise of 3D printing technology has revolutionized the rapid prototyping and production of explosives and related components. Marciniak notes that fused deposition modeling, FDM, techniques allow for the creation of intricate explosive devices with precise control over material composition and structure. This advancement improves the effectiveness of military ordnance while reducing production costs. However, the accessibility of 3D printing technology raises concerns about the proliferation of advanced explosive devices. Hussein et al. Warn that non-state actors could exploit this technology to manufacture weapons outside traditional supply chains. To mitigate these risks, international regulations and monitoring mechanisms are essential. While there have been limited confirmed cases of large-scale weapon production by non-state actors using 3D printing, early signs indicate that the risk is growing. Reports suggest that criminal organizations and extremist groups have experimented with 3D printed firearm components, indicating a potential shift toward more complex weaponry, including explosives. The primary barriers preventing widespread misuse include the high costs of industrial-grade 3D printers, the difficulty of acquiring stable explosive precursors, and the technical expertise required to create functional explosive devices. However, as these technologies become more accessible and materials science advances, these barriers may weaken over time. While regulations are often proposed as a solution, their effectiveness in this case is debatable. Non-state actors that might misuse 3D printing for illicit weapon manufacturing operate outside legal frameworks and are unlikely to comply with international treaties. This raises the question of whether international regulations and monitoring mechanisms can effectively mitigate such risks. However, regulations can still play a role in mitigating risks by controlling access to high-performance 3D printers, restricting the availability of specific printing materials used in explosive devices, and monitoring the online dissemination of digital blueprints for military equipment and explosive components. In addition, international oversight can contribute by enforcing stricter export controls on advanced 3D printing equipment. Coordinated intelligence sharing between nations can also help track and disrupt illicit manufacturing networks before they become a widespread threat. On the other hand, if the risk of misuse were negligible, the justification for strict regulation would be weaker. The reality lies somewhere in between. While full-scale use of 3D printing for explosive production by non-state actors has not yet been widely documented, the rapid pace of technological development suggests that proactive measures are necessary. Regulations alone may not entirely prevent misuse, but they can act as a deterrent, making it more difficult and costly for unauthorized actors to manufacture advanced explosives. A combination of regulatory oversight, technological safeguards, and law enforcement cooperation will be essential in addressing this emerging challenge. The military's adoption of 3D printing technology has progressed significantly over the past decade. Initially used for creating non-critical replacement parts and training models, the technology has evolved to facilitate the development of complex components, including weaponized drones, advanced explosives, and battlefield-ready munitions. Additive manufacturing is now being utilized to produce sensor components critical for modern combat operations, improving real-time data collection and battlefield awareness. One key advancement has been the use of metal additive manufacturing, which allows for printing highly durable and heat-resistant materials suitable for military-grade weaponry. This development significantly enhances the flexibility and efficiency of weapon production, ensuring that militaries can rapidly adapt to emerging threats. One of the key benefits of 3D printing is its ability to decentralize production. This capability can reduce logistical challenges, allowing for on-demand manufacturing of explosive components in conflict zones. However, it also presents risks, such as difficulties in tracking and controlling the production of dangerous materials. The military must implement stringent cybersecurity measures to prevent unauthorized replication of classified weapon designs. Furthermore, 3D printing streamlines supply chain management by reducing dependency on traditional manufacturing hubs. Instead of relying on mass production and global transportation, military forces can use portable 3D printing units to create essential parts in remote locations. This innovation reduces vulnerability to supply chain disruptions resulting from political conflicts, economic sanctions, or natural disasters. This newfound ability to print weapons and replacement parts on demand allows for extended operational capabilities in prolonged combat scenarios. However, it also raises concerns about the loss of centralized control over military technology. Effective policies and regulatory frameworks must be established to prevent unauthorized actors from leveraging 3D printing for malicious purposes. The ability to manufacture weapons outside of traditional supply chains reduces governmental oversight, making it more difficult to track the production and distribution of military-grade components. This decentralization could enable unauthorized actors, including insurgent groups and criminal organizations, to acquire and produce advanced weaponry with minimal detection. Additionally, regulatory efforts can be reinforced through technological safeguards, such as digital rights management (DRM), for 3D printed weapons and real-time tracking of industrial-grade additive manufacturing machines. Intelligence sharing between allied nations and tighter export controls on dual-use technologies could further reduce the risk of proliferation. While regulations alone may not prevent misuse, a combination of legal oversight, cybersecurity measures, and international cooperation can create significant barriers that limit unauthorized access to critical 3D printing capabilities. Beyond logistics, 3D printing is directly influencing the design and fabrication of advanced explosives. Traditional explosives manufacturing involves complex chemical processes that require significant time and resources. With additive manufacturing, military engineers can develop customized explosive devices with precise compositions tailored for specific missions. This advancement enhances lethality, efficiency, and adaptability in modern warfare. One area of focus is the production of nanostructured explosives. By utilizing nanoscale printing techniques, researchers can improve the performance and stability of explosive materials. This technology enables the creation of munitions with controlled detonation characteristics, reducing collateral damage while increasing effectiveness against hardened targets. Additionally, 3D printing allows for the rapid prototyping and testing of experimental explosive designs. Previously, developing new munitions required extensive manufacturing processes and long testing periods. Additive manufacturing reduces these time constraints, accelerating research and development efforts in military explosives engineering. The role of AI in 3D printing and explosive manufacturing. AI is increasingly being integrated into additive manufacturing processes, particularly in the design and optimization of explosives. AI-driven systems can analyze structural integrity, predict explosive performance, and automate quality control, ensuring that munitions produced via 3D printing meet military standards. While research into AI-enhanced quality control for 3D printed explosives is ongoing, some applications are already emerging in military manufacturing. AI-driven monitoring tools are being used in additive manufacturing to detect structural inconsistencies and ensure precision in sensor components for military applications. However, the full implementation of AI-driven systems specifically for explosives remains a developing field, with further advancements needed to integrate real-time predictive modeling for detonation efficiency and stability. According to the U.S. Department of Defense, 2023, AI-enhanced 3D printing processes also improve safety by minimizing human involvement in handling explosive materials. Automated additive manufacturing systems reduce exposure to hazardous chemicals, decreasing the likelihood of accidents in weapons production. Additionally, AI facilitates the rapid identification of weaknesses in explosive designs. By running millions of simulations, AI algorithms can refine munition configurations, enhancing effectiveness while minimizing unintended detonations. These advancements are crucial for developing next-generation military ordnance with superior precision and efficiency. While research is ongoing, AI is already being applied in military contexts to optimize explosive materials and predict detonation behavior with greater accuracy. AI-driven modeling has improved the reliability of modern explosives by detecting vulnerabilities in design before deployment. These advancements are crucial for developing next-generation military ordnance with superior precision and efficiency. Ethical and security challenges. Despite the advantages of technological advancements in explosives, ethical considerations remain paramount. The risk of misuse by rogue states or terrorist organizations underscores the need for stringent regulatory frameworks. Governing bodies must implement safeguards to prevent unauthorized access to nanotechnology-based explosive materials. Additionally, the ethical concerns surrounding AI-driven military operations require careful evaluation. Autonomous weapon systems capable of independent decision-making raise questions about accountability and compliance with international humanitarian laws. The Carnegie Endowment for International Peace emphasizes the importance of global governance mechanisms to regulate AI's military applications effectively. Conclusion and recommendations. The intersection of nanotechnology, AI, and 3D additive manufacturing is reshaping the landscape of military explosives and pyrotechnics. While these innovations enhance military capabilities, they also introduce complex security, ethics, and international stability challenges. Military leaders, policymakers, and researchers can leverage disruptive technologies by addressing these challenges while minimizing their associated risks. Future studies should focus on refining regulatory strategies and exploring sustainable military applications of these innovations. Ultimately, balancing technological progress with ethical responsibility is essential to maintaining global security in the modern era. The author, Doris Dasovic, Military Applications, Explosives Engineering, military engineering, technology studies. The views contained in this article are the authors alone and do not represent the views of the Croatian Ministry of Defense.
This was the Horizon Audiofiles, a podcast of the Defense Horizon Journal. For more information, go to www.tdhj.org. Thank you for listening.